my name is Pamela. Welcome to my channel. Today I'm gonna talk about... As you have seen, Pamelitos, today we are going to start studying instruments for level measurement. The use of electronic instruments with a microprocessor to measure variables such as temperature and pressure allow adding intelligence to the level measurement and obtaining measurements with accuracies of the order of plus minus 0.2%. The use of smart transmitters allows 1. The accurate measurement of the level, because it can eliminate or compensate for the influence of floating foam in the tank. 2. Elimination of false alarms caused by waves on the surface caused by paddle agitators. And 3. The easy calibration of the instrument at any point of the transmission line. Level measuring instruments can be classified into liquid and solid level methods. Today we will start talking about the first ones. This type of method can work by measuring 1. Directly the height of the liquid above the reference line. These are divided into deep stick, steel tape and bob, side glass, and chain or float gauges. 2. Hydrostatic pressure, which is used by manometric gauges, membrane gauges, bowel tube or deep tube systems, and diaphragm differential pressure transmitters. 3. The difference produced in a flow by the processed liquid. Or 4. Taking advantage of the electrical characteristics of the liquid, whose methods are resistive, conductance, capacitance, ultrasonic, radiation, laser, and radar. Today I will talk about the direct measurement instruments. The dipstick consists of a rod or a graduated ruler of the appropriate length to be inserted into the tank. The level is known by the length weighted by the liquid. When measuring, the tank must be open to the atmospheric pressure. These methods are widely used in gas tanks. Another method consists of a graduated rod with a hook that is dipped into the liquid and then raised until the hook breaks the surface. The distance from the surface to the top of the tank represents the level indirectly. A similar system is the steel tape and bob method, used when it is difficult for the graduated ruler to access the bottom of the tank. The side glass indicators consist of a glass tube with its ends connected to metal blocks and closed by cable glands that are connected to the tank by 3 bulbs, 2 of which are safety closures at the end that have a bolt inside to retain the liquid escape in case of a glass breakage, and 1 of purge. The common side glass indicator is used for pressures up to 7 bar. For higher pressures, the glass is thick, rectangular in section, and protected with a metallic armor. In those by reflection reading, the glass in contact with a liquid has longitudinal grooves that act as reflection prisms, indicating the liquid area with a dark color, and the upper area in contact with a vapor with a light color. The transparency reading is used to see the color or characteristics of the liquid and consists of 2 flat and parallel glass plates that allow the level to be seen directly. Jacketed side glass indicators are used for heating or cooling viscous or volatile liquids. The advantage of all these indicators is that the reading security is high and allows to control the reading of other level devices. As a disadvantage, they can get dirty pretty fast depending on the liquid, which makes it difficult to see the level clearly. Also, they only allow local indications. Float gauges consist of a float located in the liquid and connected to the outside of the tank, directly indicating the level. The connection can be direct, magnetic, or hydraulic. The directly connected float is connected by a cable that slides a set of pulleys to another index, pointing on a graduated scale. It is the oldest model and it is used in large capacity tanks such as fuel oil and gas oil. The disadvantage is that its moving parts are exposed to the fluid and can break apart. Plus, the tank can't be pressurized, and the float must remain clean. The magnetically coupled floats slide externally along a steel guide tube placed vertically inside the tank. Inside the tube, there is a magnetic piece that follows the movement of the float and that by means of a cable and a set of pulleys drags the index of an instrument located in the upper part of the tank. This instrument can also be a pneumatic, electronic, or digital transmitter. A variant of magnetic connection is where the float, equipped with a magnet, is inside the tube. The magnet orients to a series of magnetic tapes arranged outside and along the tube. As the level changes, the ribbons, which have different colors on their front and back, rotate and show the level of the tank. These instruments may have built-in transmitter and alarm switches, and they replace the use of side glass when 0.5 bar. B. There is high probability of glass breakage. C. The escape of toxic gases, flammable liquids, etc. must be avoided. D. The tanks are buried or the level needs to be viewed from a distance. And E. When the liquids are dirty or viscous. For small tanks, the flow can be adapted to act magnetically on the transmitter. A typical application is the level control of a small capacity boiler that produces steam. The hydraulic coupled float acts on a bellow, which modifies a hydraulic circuit. It allows transmission distances of up to 75 meters and can be used in closed tanks. The disadvantages are that its installation and calibration are complicated. It has moving parts inside the tank. The float can get stuck in the guide tube by some deposits of solids or crystals in the liquid, and the long guide tubes can be damaged by the sudden waves of the surface or by the violent fall of liquid in the tank. The last direct measurement instruments that I will talk about are the servo-level gauges. These have a displacement disc suspended by a stainless steel cable, which is coupled to a precision machine with a grooved drum, which stores or dispenses the cable. This drum is driven by a controlled servo motor and mounted on precision bearings. When the level varies, the displacer rises or falls automatically, maintaining contact with the surface of the liquid. The measuring drum is mounted on the roof of the tank and has an optical encoder and a transmitter. Transmission is generally digital. To protect the disc from the surge that may occur, a steel pipe with holes is installed. This method has a repeatability of ±0.5 mm, a resolution of 1 mm, and a measurement speed of 5 mm per second. And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adios! Used in a flow by the tanks are buried or the tanks are